Hello everybody and welcome back. So now that we've learned a little bit about Python and the syntax, and then we've been working with nodes and parameters, now let's fully bring this kind of full circle and package it all together into something useful. So I want to show you really what I've been talking about when I say Python on the go. Basically, the types of things where you're working within Houdini. These are not long-term kind of building massive tools, pipelines, HDAs and things, but actually just being able to use Python as a quick way to work with your scene. And it just, knowing the expressions, knowing how to work with Python just gives you this additional tool that a lot of other people don't have that speed up your workflow. And I can honestly say that I use it all the time, because so many times people come to me asking, is there a quick and easy way to do this? Nobody likes to do anything laborious, repetitive, boring, especially when you're under pressure, there's deadlines, people just want to go click a button and it must quickly happen. But there's no point in building a tool when it's a very specific and unique scenario. So your ability to now work with Python and be able to essentially just tell it, listen, this is what I want. I've got 100 nodes and I want you to go and do this on every node. That is the true power of Python, that you can very quickly in a couple of lines save yourself hours. Right. And we've built up all of the little tools that we need in order to do this. We understand the language a lot better. We've spoken about the classes and functions that we're going to use. So now let's put this into practice. So I have a scene here, and I'll happily provide this scene for you guys if you want to use it as a start. But really, it doesn't matter. You don't have to follow along with the exact scene. I'll explain what I've done. So I've got a box. I've got a grid. I'm copying the box to the points of the grid, and I'm coloring the result. Right now, what I've done on the outside is I've created a null, which I often do this when I want to sort of create like controls for reference in the scene. Several nodes are all referencing things. I want to tweak parameters. I like to kind of gather them on one node and be able to just tweak it here and maybe kick off a new simulation or something like that. And I often make it red and I make it a big circle, because this is to me the shape that sort of stands out the most. It takes up the most like space and it looks odd, so it just kind of stands out as a control. So I always do this. I mean, it's up to you how you handle it, but this is just a technique that we often use in FX. So on here I've got some parameters. I've just created them going to the edit parameter interface, dragging in a couple of parameters into a folder over here and giving them a name, right? So I've got a two integer vector, right? So two integers basically, x and y. And then I've got a float value here, and I've got a color value, which actually has a color wheel and everything that pops up, because it specifically is marked as a color attribute, not just any vector. Right, and I've linked these to the divisions of my grid, x and y, the scale of the box itself, and the color at the end. So this is just an example of a scene that has a bunch of parameter references, and that's the main thing here, is the fact that they are referencing a particular node and parameter, right? Now, what happens in Houdini is if you go and rename something, okay, so we go and rename this control 1, nothing breaks, because the parameters, the expressions just go and figure out that, okay, hang on, it used to be called control, now it's called control 1, although hang on, that doesn't seem to have done something. Okay, that's a bit strange. Look at that, on the box, scale, the expression hasn't actually changed, but it's still finding the reference here. It's probably just a display glitch, like that in here it's maybe just hasn't updated itself yet. Maybe if we disable and re-enable. Okay. Well, either way, basically that's a little unfortunate glitch because it kind of muddies the issue here. But essentially, when you do change it and rename it to control 1, it now looks for, you know, it changes the parameters to look for control 1, not control, and that's why these parameters still work. Okay, so that's all fine and well. That's what's supposed to happen, right? But sometimes, and there's a variety of situations that will cause it to happen, but you end up with something that's linked to the wrong thing, okay? And it becomes very difficult to then rename it. For example, if we had to then maybe copy this in from another scene or something like that, and or you know, merge two scenes together, and we end up with two controls, and because it was imported this way, this parameter, like these parameters, will all reference control 1, and these ones will reference control 2. Well, sorry, not control 2, control, right? So just control, and then this one will reference control 1, which, you know, in the short term, this seems to work because, of course, if I wanna scale this one, that's working fine. What I'll probably do is I'm just going to translate this one over here on the top level, just so we can see the two of them, right? So this works all fine and well if this is the result I want. I wanted to copy it into my scene, but actually I want both controls separate. But the problem comes in now, what if I want to combine these? You know, what if I want to actually just redirect all of these parameter references to something else? Now, honestly, you know, 1, 2, 3, and then 4 references. Well, I guess if you want to count these 3 as individual, then, you know, it's 6 references in total. Is not a lot, but this has happened to me before. Honestly, like in my scenes, physically happens to me several times per project where we are copying something over and there's an entire section, you know, like 100 nodes that are all just have broken references, because some node that should have existed now doesn't exist anymore. And even when you bring the node back, because it's named differently, it now can't relink. Okay, so for example, we go and take this control 1 and delete it, right? So now this one still references control, but this one is looking for control 1 and can't find it. Right? It's not that we can just go and rename control 1 to control in order to link it, because if we tried to rename it to control, it just renames itself to control 1. So like there is no way to kind of just very quickly redirect all of those parameters to a different node, except Python, right? So Python to the rescue. This is how we're going to use Python to quickly resolve something in our scene, and in a scenario that does happen quite often. Right, so let's pop open the Python source editor just so that we can kind of type multiple lines of code here, because we're beyond the point of just doing quick little references and stuff with our Python shell. However, I am going to just make sure that we split. Let's go left, right over here and just make sure we include, I'm actually going to put this one over here. Oh, okay, let's just zoom out here. Whoops. I'll just zoom out so we can see what we're doing in this. Shift this over, and I'm going to make this one a Python shell, just so we've got some place to print if we need to, right? But we're going to work in here because we're working with multiple lines of code, and it's just easier, right? So this is a bit odd. Let's just create a new scene view. Okay, there we are. Right. So what we want to do, if we were to do this manually, and this is always how I start trying to figure out how to write code, is I think to myself, just very logically, what is it that I would do? If I was going to do this manually, what would I do? Because ultimately what we're doing is building the code to do exactly what we would do. It's got to follow the same steps because obviously we're changing it in a logical way. So what I would do is I would click on the node, I would go to the parameter, and I would take the expression as it is and replace this control 1 with just control. So I would hit backspace over here and then enter, and then that is fine, right? That one works, right? But I would want to do that on every node. Now I just want to reiterate here and just stress that, of course, with 6 things, you could just go and do it manually, because it'll actually be quicker to go and do it manually on 6 things than write a few lines of code. Because, you know, I mean, that 6 is fine. But let's say we had 100 referencing this. I mean, that's just way too crazy to go and reference, especially if it's not just all on one level. It's things inside of subnets, multiple references, different things. So imagine that this is a lot more extensive, okay? And we've decided that this is just going to take us too long. But manually, to do one, what I would do is go and just alter the expression of this parameter, okay? So now, with that, like equipped with that knowledge of what we would do manually, let's go and write the code to do it for us. So now, the first thing, and don't forget steps that you did manually. The thing is, for me to even go to that parameter, I had to go inside of this node. Like I literally, it's almost like every time I click, I'm sure you guys can actually hear this. This is like a really loud mouse, so I'm sure you can hear me clicking, right? Every time I click, that kind of needs to be a line of code. A lot of the time I ask people when I'm trying to teach them coding, oh, so what would you do to change this? And they say, the first thing they say is, oh, I'd change the parameter, you know, I change the expression. I'm like, no, hang on, wait, you're not even at the expression yet. Where are you? You're on OBJ level. So what is the first thing you actually do? I dive inside of this node, click on this node, go to the parameter, look at its expression. Like every click that I've just done is something that we have to write in code, okay? Now that may sound a lot, but when you're talking about changing 100 parameters, that's 100 times the amount of clicks. It's easier to write one line and put it inside a loop rather than having to click 100 times, right? So, diving inside of this node and going to all the nodes inside looking for expressions. So that's where we're going to start. Okay. So, again, I'm just going to stick with my old habit of importing the who module. Lately, I've noticed that it actually seems better, so maybe this is redundant, but I don't know. I still think it's a good habit. Now, what we want to do is we want to go through all of the nodes inside of this node. So multiple nodes inside of here may have the parameters, and so what we want to do is go through everything here. But also, there might even be multiple nodes that are referencing this. So I want to go through my selection. Because I don't want to have to run it here, like I don't want to have to run this 100 times as well. That kind of defeats the point. So I might as well just run it on my selection. And for every node that I have selected, I want to go inside and go through every node that it has. Okay. So what I just said in English, you know, the sentence that I said is actually a hint as to how we start writing this. And I always tell people when I'm teaching them coding, say it out loud. Tell me what you're going to do, and then write down exactly what the line, like record yourself saying it and then play it back to yourself and go, those are the lines of code I need to write, the things that I just said, right? So going through my selection, well, that is something that we covered in a couple of lessons ago, where we said the who.selected nodes. Right? So this function allows us to gather a list of all of our selected nodes. Now what do we want to do with this list of nodes? We want to loop through it, because everything that we do to one node we want to do to the other node. And so that is the perfect time to use a loop. So we say for, and then I'm just going to call this n, which is because it's a bunch of nodes. So for each node would be called n as we're looping. So I'm going to say for n in who.selected nodes. Okay. So now on the first iteration, n is go2. On the second iteration, n is go3. So now when we have a reference n to go2, we want to look at all the nodes inside of it. Well, how do we look at all the nodes inside of something? It's n.children, okay? N because that's the variable that we've given to the name of the node, but then dot children gives me all the nodes inside of this. So it's going to give me a list of 4 nodes, right? So what I want to do is loop through each of these nodes as well, because for each node I want to go and make a change to something, right? What I'm doing is actually looking on each node for parameters that have expressions, because I want to change those expressions. So we need to loop through these children as well. Now remember, I said when we're doing nested looping, you cannot have the same variable. So we're not going to say for n, but let's say for c in, because c is child. So n is the parent node, but c is the child. Okay. So for c in n.children. So now as we loop, the first time this loops, it looks at Geo2. It looks inside of it for all the children and loops through every child, where the first time it loops C is box 1, then it's grid 1, then it's copy to points 1, and so on, right? So assuming that we're now looking at box 1, where C is equal to box 1, what do we want to do? We want to go through all of its parameters looking for expressions. Well, how do we look through a bunch of parameters? Well, we need a list of those parameters. And how do we get the list of parameters? We do a reference to the node, which is C in this case, c.parms. And that gives us a list of parameters. So now we're going to loop through this list. So again, we're just doing nested looping here. So we're going to say for, and then let's call it p, for p in c.parms, right? Because p for parameters. So now p is equal to each parameter as we loop through it. And remember, it's parameters, not parm tuples. So it'll be size x, size y, and size z will be handled individually. Okay. In this case, it doesn't matter, but when we get to the color, it does matter, because we want to go and change this one and this one and this one, right? As opposed to the parm tuple as a whole. So we're now going to go to this expression, but because we're looping through every parameter, we first want to check whether actually we need to change anything. And then what is the difference between this parameter that requires no change versus this parameter that requires us to change something? Well, the difference is that it has a keyframe. Now remember, I said that expressions are keyframes. So saying, does it have an expression, is the same as saying, does it have a keyframe? Okay. Yes, sure, the individual data of that keyframe, trying to differentiate between an expression and a keyframe, then you have to go a little bit deeper. But just on the surface, trying to say, well, a node that has neither versus a node that has an expression or a keyframe, we can just use the keyframe to check. So what we do is we call p dot keyframes. Okay. So that's going to return a list of the keyframes. But I don't really care how many keyframes there are, because if it's an expression, it should only have one. But I really don't care how many there are. All I want to know is whether there is one or not. And so I just want to check whether there is more than 0. So first of all, this is a list of actual items. To check the size of the list, the number of items in the list, we'd use len. So I'm going to say, inside of this loop, when we know what p is, which is each parameter, we're going to say, okay, look at your list of keyframes. Tell me how many there are. Okay. So size over here, size x, is going to say, 0. You know, how many keyframes do you have? Well, it's going to return an empty list. So then we say, well, how many of those are in, how big is your list? And it says 0. So we say if, so we're going to use an if statement here, if len of p.keyframes is greater than 0. In other words, are there more than 0 keyframes on the parameter that I'm examining? So it's going to go to this parameter first. Well, technically it'll start at the top here. So it's going to look at type. Then it's going to look at surf type. Then it's going to look at this one. And it's going to go to each one and say, how many keyframes do you have? Is it more than 0? And only if it says, yeah, I have more than 0. I've got one. I've got an expression. I've got a keyframe. Then we're going to do something. So in this block, we're going to do something. And if it's not true, if this is false, then we're just going to have nothing. So it's going to do nothing, right? So it's going to be a very quick expression because it's only going to do something when it finds an expression. Now, what do we need to do here? Well, the first thing I'd like to do, for safety's sake, is store the expression as it is. Because I want to alter this expression, and then I just want to set an expression. So I basically want to overwrite the expression. But in order to make a change, we need to store it. So I'm going to say expr. I'm just going to call it expression, sort of like a short way of saying expression, as my variable name. Okay. I use single letters when we're doing just loops and stuff because it's easier, but when we get down to actual blocks, I like to use a little bit more descriptive things. So I'll say expression equals, and then I'm going to grab the expression. Now p is still our variable that we want to reference. Remember, inside of here we can reference n, c, and p because we are inside of all of those blocks. We're nested inside, but really what we want to do is look at p. And we're going to say p will give me the expression that you currently have. So let's do p.expression and store that in this variable. So now this is just a string. This is a string. It has no reference to the variable. So if I change this, it has no reference to the parameter, right? It's just the resulting expression from that parameter. So if I change expr, this will not change at all. But that's fine. We're gonna implement that. So we're gonna say first, let's fix what expr says. Now let's examine this. Right? Here's a string, and it's an expression. We're not changing the entire thing. We're not rewriting the entire thing. All we're doing is replacing the 1 with nothing. Okay. So what we could do is go and write an expression, which with strings, we can go and replace. There's a replace function, which is obviously what we want to use, because we want to go and say, well, replace a 1 with a 0. Well, 1 with a nothing. But the problem with that is that it's a little bit vague. You know, what if we were accidentally referencing, maybe box scale is correct, but then maybe on, maybe it wasn't col R, col G, col B, maybe it was 0, 1, and 2. So somewhere in this expression, there's a 1 here, but there's also a 1 here. So when we do a replace, you have to be very careful. You can't be too vague. So I want to give it a little bit more information. But I know that every time I'm going to be looking for where it says the entire word control in capital letters and ending with a 1. And then replacing that with the word control in capital letters, and that's it, nothing else. That gives me enough information to be not vague. It gives me enough to be specific enough, because now it doesn't matter if there was a 1 at the end of box scale, because it doesn't care that there's just a 1. It wants the entire word. All right, so that's what we're going to do. We're going to say expression equals, right, because the replace function returns the result. It doesn't act in place. And so what we need to do is say expr equals, and then we're going to do expr.replace. Now what we do is we say what we're replacing, and then then the second argument is what we're replacing it with. So we're going to say, all right, well, go through and look for the word control1 like that. But replace it with the word control. All right? So now expr is fixed, but our value over here is still broken. So what we're going to need to do is say p, which we still have our reference to p dot set expression. Remember, we covered this one last time. So set expression. It wants self, which we've already given it, p dot. It wants the expression, so that's the expression, the new expression that we wanted to have. And then it wants a language, which if it's none, if you read in here, it'll tell you that when it's none, it's going to be HScript by default. And since there is only HScript and Python in here, we know what we want is HScript. Okay. If we wanted to be more advanced with this, we could go and check what the old expression language was. But honestly, in this case, we know the parameters of this. We know that everything is an HScript expression because it's just a parameter reference. All right. and then replace expression equals true by default, and that is exactly what we want to do. It's replace the expression, not add to it. So we just say p.setExpression and we give it expr. All right. So let's run through the logic here very quickly again. We say for every node that we have selected, loop through them. So go to one node at a time. Then on that node, look at all of its children. Go through each of those nodes one at a time and look at its parameters. Go through each of those parameters one at a time and ask yourself, how many keyframes do you have? If you have more than 0 keyframes, then do the following. Grab the expression that you currently have, store it in a variable, replace all instances of the word control1 with control in that expression, so in that string variable, and now go and to that same parameter, set an expression to be equal to the new fixed expression. That's pretty much exactly what we do as people. We go, oh, I'm going to go through each of these nodes. I click in here, I go through, literally clicking, going through each node, looking at each parameter, going, where are the keyframes? Oh, this one's got a keyframe. What do I need to do? I need to replace this with that. Okay, so that's exactly what we've told it to do here. And now, if we grab our selection and we click apply, this grid suddenly appears. And it appears because we fixed the code. Once we go inside, you'll see that box 1 is now, it's got control, not control 1, so it's referencing that. It's finding the value correctly. Our rows and columns are correct because they're looking at control. And here, fixed as well. So everything is fine. And in fact, we have overlapping grid as well because we've duplicated it here. Right. So this should work perfectly fine, and it's non-destructive as well. I can click apply again and it won't break anything because it's only replacing control1 with control. Once it's already control, it won't replace it with anything because it won't find this. So it's looping through and finding nothing and doing nothing. Okay. All right. Now, if you're trying to build this and follow along, I mean, obviously you can follow along line by line, but if you were building this up line by line as you go, you would want to maybe print a lot as you go along to see what's happening. So you can, as you go, just say, well, as we loop through, just say print n, okay? So for instance, for argument's sake, I'm going to swap these around so that it actually goes and re-breaks the expressions on here, swapping the word control for control1. But what I'm doing as I go is every time in this loop, I'm going to print n, okay? So as I click it, it loops, because I only had one thing selected, right? But if I have two things selected, it prints Go2 and then Go3, right? We can then go and even print C to see what children it's looping through as we go, okay? You can print P to see which parameter it's busy examining. Okay, so now for each one, you'll see it's going to go to grid 1, then print its parameters. Then it's going to color 1, print all of its parameters. Geo3, grid 1, each parameter, and so on. You can see how it's looping, right? And at each stage, we can double check what we're doing. So I always use print as a way to sort of figure out what I'm doing. Over here, I can double check that this is working by first just saying print expr, but without this line, with this one, with this line disabled. So before I make any actual change, I always print to check that what I'm doing is working. So we go here and click apply, and for every node that it finds, well, every parameter that it finds with more keyframes, it's going to print the expression once fixed. Now I can look at that and see what it is, and it's gone, oh, control1. In fact, what's been happening every time I've been clicking apply is because it's finding the word control. It doesn't care that there's following ones, it just goes control, and it's replacing it with control1, so it's actually adding a 1 every time. Now that's obviously pretty bad, right? So now we should have been more specific about going, maybe we specifically know it and it should be control slash. Okay. So, or even maybe even slash control slash, and then replace it with slash control 1 slash. Okay, that would have been better, because then we wouldn't have ended up with this, right? Now let's go and fix that. We can see here that there's just what's it, 1, 2, 3, 4 ones, although these ones have 5, so we can just go do it twice. But we could actually build a way of like going and saying, no, it doesn't matter how many ones there are, just keep going and replacing, right? So we're going to go replace all of that. So replace, and now we still have ones with 3 ones, so let's go and replace those. Okay, and okay, this has just become a little bit of a mess, because these are all referencing, how many ones do we have there? 4. Right. Well, anyway, doesn't matter. We can go clean that up, but essentially this is the type of thing we can do, right? Is print to check what the changed fixed expression is. Oh yeah, sorry, that's why it's not fixing it, is because we're not actually applying the change, we're just printing the change, right? Okay, so that's quite funny. So yeah, we can go through and fix that if we just undo this, so allow this expression to actually take place, and we go and replace all of them with 5 ones. So it'll fix that one, but this one still has 3 ones, so we can go and where is it? 3? Yeah, is it 3? Yes, it's 3. Can go and fix that one as well, and now they'll all be fixed. Okay, so this is exactly a good example of what I was saying, where the slashes or being more specific helps you avoid making weird mistakes like getting multiple ones, right? I also just want to caution you to always save your scene or whatever before writing expressions and things. Be very careful, because this can be destructive. Okay. Because it can do everything that you can do, it also means that it doesn't have the same brain as you. If you start tweaking things, and your whole scene starts crashing and breaking, you'll stop. But Python won't unless you teach it to stop and say, look for this, and if this is happening, then stop. And if you don't teach it, it's going to be a bit destructive. So just be a little bit careful. Right. So that's a good example, and something that I use all the time to fix broken expressions, because it happens a lot that you end up with something in your scene that was referencing something that no longer exists. Okay. Now, let's move on to another example, something that also happens a lot. So let me show you what I've got here. Again, you can recreate it, but if you want to, I will still share the scene. But I normally only share things at the end of the week, because I don't want to I don't want you to be tempted to just not do the assignments and stuff. So just you can just recreate this really easily. I dropped down a test geometry thing, okay? But specifically, I use this crag because it's got lots of nice separate individual pieces to it. Okay, these are all little packed alembics. Okay, so there's a whole lot of different things. Sorry, not packed alembics, just packed primitives. And I've got a ROP alembic that I'm writing out. So I'm writing it out to a specific location as an alembic. I'm not doing the frame range because I didn't need it. I'm just wanting to do it on one frame, and that's it. That's literally all I'm doing, is with all default settings, just pointing it to a location and writing it out. Okay. And then what I'm doing is I'm reading it in with an Alembic archive node. Now this separates all of the packed primitives into different geometry nodes inside. Okay. So what you do is you reference the actual Alembic, and then you click on build or update hierarchy. And what it goes and does is it rebuilds the hierarchy of those nodes. So because inside of Geo1 there was this, and it treats each packed primitive as its own object, so it has kind of a path. It rebuilds that hierarchy in here. So inside it'll create a thing called Geo1, and inside of this it creates a whole lot of nodes, each one with an Alembic node that references just one part of that object. Okay, so now we have multiple pieces of this test geometry. Now this is a technique that we use a lot at work, so I'm sure a lot of other studios use this as well, the Alembic archive node, because it's really good for like material assignment and that type of stuff. So this is something that we come across a lot. Now the biggest problem, and I've had several times people in the studio asking if I can build them something for this, is because look at how many nodes there are. And now they go, oh, yeah, actually what we want to do is create like a proxy of this, and this is way too high geometry, so can you just, I want to go to this node, right? And okay, it's packed, so first thing I want to do is unpack it, okay? And then it's got a ton of geometry, I mean, especially considering how many pieces there are, so we go, and I want to poly reduce this, right? Because I just want a proxy, or just a very low res representation of this. So I want to keep maybe only 10%. Okay, so now I have much less geometry, but I'd also like to repack this, okay, so that it is still packed. Now that's what I want to do, but I want to do it in every one of these nodes. Okay, so once again, like we just did, let's go through that and double check what we're going to write into the code. We need to go to each node that we've got selected and go inside of it. Now this is an Alembic XForm node, but you notice that these are geometry nodes. So what differentiates the nodes that we want to actually work on from the node that we don't want to work on? Because we don't want to go inside of this and try and drop down an unpack. I mean, there is no such thing as an unpack on this level, and therefore the code will error. We don't want to do that, so we want to be careful and say we specifically want to reference the geometry nodes only. Not ones called geo, but actually, look at this. This is called an Alembic XForm. If you middle click, you'll also see Alembic XForm is the type, whereas these are the type geometry, and these are all the nodes that we want to actually work with. Now sure, we could ask the user to go and select all of these nodes and run our script. We could do it that way. But I prefer to do things where I allow them to select the parent node at the topmost level, and I want my script to do all the diving. I want it to dive inside and collect a list of all of the geometry nodes that are inside of there and act upon them. Okay, so that's what we're going to do. And then for each one, we're going to go inside, we're going to create a new node, right? In fact, I want you to watch very carefully what I do. I'm going to do it again, right? Because it's important to know this, right? Unpack, drop it down, plug it in. Okay, these are all steps. Poly reduce, drop it down, plug it into the first input. Change, actually, before we move on, change this to 10. Change the parameter value. Drop down the pack node, plug it in, and as a final step, move the display and render flag. Okay, so I hope you've been following there and taking down notes of these steps, because this is what we're going to try and code. And in fact, if you're feeling more comfortable now, why don't you maybe try and code this yourself before I actually show you, so you can see if you can do it, or see how far you can get, because that's going to be how you'll learn the most. All right, so if you've gone and done that and been successful, then fantastic. If not, let's do it one step at a time. Right, so Python source editor again. We've got our shell open here if we want to do any printing. So import the Houdini module, and let's go. Now, the first thing I'm going to do is gather a list of all the geometry nodes that I'm going to work on. Now, assuming that I've got multiple Alembic archive nodes as well, okay, so we want to go through each of them. I'm going to need to look through my who.selected nodes, right? So that's, again, something who.selected nodes. And we're going to loop through this. So for n in who.selected nodes, all right? Now I want to go through everything, but I know that it doesn't matter. Even if I had multiple nodes inside of here, I want to go through every sub node, looking at every level, no matter how many levels deep. And believe me, with these Alembic archives, you can go very, like, loads of levels deep. So I don't want to really have to be too specific about how deep I want to go. I just want to say gather everything. So here we're going to use our all sub children function instead of just children. Okay. So inside of this n, we're going to say for c in n dot all sub children, which is going to give us just a giant list of every single node, which includes even this node, right? So we've got an Alembic node, we'll have a bunch of geometry nodes, we'll have a bunch of Alembic X-form nodes. So we need to sift through that list. So C is not going to be something consistent. We need to clean C up. So we first want to check its type. Now remember, if we take C, we can ask for the node type, but that's going to return a type object. And I don't really want to work with a type object. I want to compare something that is actually easy to compare, because I don't know if this type has an equivalency magic method coded into it. And I don't want to assume that. So instead, if I just say type.name, and if you remember we did cover this, c.type.name, then I want to compare this to the type that I'm specifically after. And I know that I'm looking for geometry nodes, so it's geo. I happen to know that off by heart, but you don't have to know it. You can just dive inside, go and look at your scene, and middle click. Now let me just point out something. You never code just with code. Like, you're just looking at text. The thing is, if someone's asked you to fix something, write them some code that does this. You need an example scene. You need to actually build your stuff when there's something physically here for you to test it on. Because you don't just code lines and lines and lines and lines and get it all perfect from the beginning. Like, maybe the more experienced you get, yes, but in the beginning, you're going to need to experiment. So you need an actual scene where something is broken the way you want it to be. Like, they need to give you the scene that is broken. Okay? And you even save it separately, so you make sure you don't accidentally, because the thing is, you could make it worse if you don't code it properly. So you save it separately, and then you actually go and try it. So we're diving inside and going, I know I need this node. What type is this? Now you can middle click, or you can even just drag this in here and say, okay, hang on, if I do this dot type dot name, sorry, I know you guys can't see it here with this where it says Indie edition, but I've typed the thing dot type dot name. Okay, let me show you over here. There we are. So that whole reference dot type dot name, it's going to return the word geo. So now I know that I can put that in here, and if I compare it, in fact, if I want to, I can even test it. All right, drag this in, say dot type dot name equals geo. All right. So this is a test for what I'm doing here. If I click that and it says true, but then I do the same thing to maybe this node to make sure, because I always want to double check that it's not just always going to return true, that it actually is correctly working. Then I'm going to say .type.name equals geo, and that returns false. Okay, I've now tested the fact that I can correctly compare the type of a node using its node type name. All right. So now that we know that we can do that, let's put this in an if block. So we say if this is equal to geo. So now we know that C is geo, because if it isn't, it's going to skip this block and do nothing to it and just move on to the next one. So what do we want to do with C? Well, because I want to loop through C, but I don't want to also, we've got these other nodes that are not, that don't belong in C. So instead of doing this, sometimes instead of writing the block of code here, I'm actually going to just gather this into a new list, and then afterwards just loop through my clean list. Okay, so let's do that as an example. In this case, it may not be that necessary, but it's a good thing to know, and sometimes I do it just for for safety's sake and for sort of clarity of what I'm doing. So I'm going to gather all the geometry nodes. So I'm going to call my variable geonodes, and I'm going to make it an empty list. And now we're going to add to this list every node that we find that fits this description. So inside of here, if it passes this test, then we're going to say geonodes.append. So remember, that's how we add to a list. And we're going to append C. So outside of this block, we should have now a list of geometry nodes that all meet this description. So they're part of our selected nodes, subchildren, and they are of type geo. Now let's test that. Let's not assume, let's actually test. So let's print geonodes. Now if I grab this selection, okay, let's maybe create a bit of space here so we can see the printing. And then I click apply, right? And it prints this really long giant list of nodes. And of course it's a giant list because there's a load of them, right? There's that many. Now if I grab 2 of them and click print, it's going to be even longer. Okay. And another way we can double check that we've got this correct is we can go maybe print len of geonodes. So we want to ask how many nodes are selected. Okay. Now if I have 2 selected, I click apply, it says you've got 134 nodes selected. If I dive inside, grab all the geonodes, and then you'll see it says 138 objects selected. Okay. Oh no, hang on, 67, sorry, there was 138 objects in total in the scene, but then 67 selected, right? And in here, there's obviously another 67 selected, and those 67 plus 67 will be 134, okay? So we can kind of use this to double check before we move on. We can confirm that we're correct. So now we've got a list of all of our geometry nodes. Now what did we do to each geometry node? Well, we went inside and we created a node. That's the first thing we did. What node? A pack node. Sorry, unpack first. So remember, to create a node inside of a node, we can do this, right? And again, I always do a single first test before I add it into my code. So we'll go here and we'll just say n equals, and we'll create a reference to this node. Now to create a node inside of it, we say n dot create node, and then we need to give it a type. Now we don't know what the type of an unpack node is, and you should never assume, because some of them are named very weird. The actual name of it is not the same as what you'd expect. So if I middle click, you see that it is, okay, in this case it is what we'd expect. It's called unpack. Okay, so let's go and create an unpack node. So we give it a type. We don't need to give it a name or anything else. We just give it unpack. And look at that. It has gone and created a node for us. Right. Now, what was weird is that it was on top of the other node. So that's something we need to watch out for. That's maybe something we need to add to our list, is putting this node in the correct place, right? Because we want them to be in a nice order. And I've got a very cool and cheap way to do that. Rather than actually having to go and place each node. Okay, so we know we can create a node, so let's go and add that into our code. So we're going to loop through our list of geometry nodes that we know are the correct nodes, right? So we're going to say for, and then maybe let's just call it geo in geonodes. So geo is our variable, so every time, for every geometry node, it'll be called geo. Now what we want to do is we want to create that node inside of here, right? But one thing I want to do, and this is just because of doing coding for so long, like I always want to have a reference to this node. I mean, for one thing, we know that once we've dropped down the unpack, we're going to need to plug this in. And so in order for me to reference this node that's already there, the easiest way to do that is grab the children of this node, because right now, before we do anything, before we start adding nodes, there is only one child inside of this node. And so let's, as a very first step, go and set a variable. So I'm just going to call this I'm going to call it Alembic, because it's my Alembic node, right? So Alembic equals, and we're going to grab a reference to this. So geo is our actual geometry node. So we can say geo.children. But we know that that's going to be a list of 1, but it will still be a list. Even if it's 1, it's still a list. So what we want to do is grab the first instance in that list, which is 0, right? And we can double check by saying print Alembic, and let's confirm. right? So we, on the top level, we click apply, and for each one of them, it has gone and printed the name of that Alembic node that is inside of each one. So we dive inside, and it goes and prints a reference to that Alembic, which is over there. Okay. If we're not sure that that's working correctly, we can even say alembic.type and print it again. So let's select it on the top, print again, and you'll see it's grabbing that Alembic type. Okay, so this is working correctly. So we now have a way to reference that node that is already in there. And now we want to create a new one. So again, we're going to say geo.create node, and the type is unpack. But once we've created this node, we want to plug it in. And if we want to plug it in, we need to reference it. And we're going to need to do other things with it, rearrange where it is. So we want to remember that when we looked at the create node function, if we go and check it in the contents here, it returns a reference to the node that it just created. So let's be smart and store that in a variable while we have the chance, because otherwise we have to go and find it the same way we have to do here, where we have to go and actually find a very smart way of gathering a reference to the node. Well, we don't want to have to do that. So since it gives us a free reference to that node, we might as well use it. So we go here, create node, and it returns a reference to the who.node. Okay, so we're going to store this. And what is this? We're creating our unpack node, so I'm just going to call it unpack. Okay, so you'll see how more explicit I am with my variables when we're inside a proper block. Right, so let's do that. Okay. Although what we should do is after the first version, because we're going to be looping through multiple nodes here, we're going to loop through all of them, and I don't want to do that. I want to just test on one. So let's say after the first iteration at the end here, I'm just going to say break, which is going to break this loop. So it's only going to happen once. So now when I select it and I click apply, when I jump inside of here will be an unpack node, but if we go into the next one, there will be nothing, because we broke the loop after the first iteration. Okay. Right, so now that we've created this, it was on top, which is bad, and also it wasn't plugged in. Okay, so let's do that, right? Let's make sure that we find a way to plug it in. Okay, so remember, to plug it in, we actually plug in from the from this node first. Essentially, we take this and plug in an input, as opposed to selecting this node and plugging in an output. I know that when I'm physically selecting it, like doing it, I don't know how you guys do it, but personally I do that. But the code wants to do it the other way around and take this and plug it in to the input. Okay, so we're going to take unpack, which is the reference to this node, and we're going to say set input. Now remember, if you remember our set input function, okay, let's have a look at it. Set input. It wants an index, it wants the item that's being plugged into it, and then it wants the output index, but that defaults to 0. Now this only has one, so we don't have to use it, but which input of unpack do we want to plug it into? Well, 0, because there is only one. Okay, so that's the first one. And then the reference to the object that we want to plug into it. So that is our Alembic. Okay, so Alembic. Because remember, this is an actual node reference, so this is correct. And then we don't need to put anything afterwards. Okay, so let's delete this and go back up and test. So we click this and we click apply. Dive inside. And once again, it's created it. It's in a bit of a bad position, but at least we have it plugged in. Okay, so now we're going to do the same thing for the other types of nodes. So let's move a little quicker through this so we don't get too bored. So we're going to create a polyreduce node. So we're going to call it reduce and say geo.create node. And let's just double check what type a polyreduce is. So let's drop it down, middle click. Now you're going to see something here. It's called polyreduce, but it has this double colon and then 2.0. This is a namespace versioning, all right? I will go into more detail with this later, but basically for now, you can assume that it is not part of the name. Okay. You can reference it using that name. So if we said create a polyreduce : 2.0, it will create a polyreduce node. But we can also get a polyreduce node just by typing the word polyreduce and just drop everything after the double colon. Okay. So I'll explain again later, but for now, let's keep it simple and just know that you can reference just the name, you don't have to reference the version. Okay, so polyreduce, right? So that's the node that we're creating. We want to plug it in to our unpack node. So again, we're going to do something similar. We're going to say reduce.setInput 0, and then we're going to plug it into our unpack. But now there's something else that we did with the polyreduce, remember, when we plugged it in, is that we went and set its parameter percentage to keep to 10. Okay. Now let's hover over percentage to keep and look at what its parameter name is. Because Python, like any of the other coding in Houdini, only cares about the name. The label is for us as humans to read, percentage to keep. But percentage, the parameter name, that's for code. Okay, and that's what we're working with. So we're going to now go to that parameter and set it to be equal to 10. So we go to our node itself, and on that node we can reference a parameter. So we do node.parm. On the parm, because we're on the node already, we don't have to give it a path, just the name of the node, of the parameter, sorry, and that is percentage. Okay, just make sure we spell it correctly. Now, once we've got a reference to percentage, that's not enough. We need to change this value. So at the end of this, we say .set. And what do we want to set it to? 10. Okay. Right, so let's stop there. Let's clear out this. Let's delete over here and double check that this is working before we move on. So again, I'm going to click apply, dive inside, and here we go. Now it's obviously, I'm going to just hit L on my keyboard to lay these out. Now you'll see everything's plugged in the correct order. You see as well, I plugged it into the first input because of plugging in to 0 over here. If we put a 1, it would plug into this one. And if we put a 2, it would plug in to this one. Okay, but 0 is fine. And you'll see over here that it changed percentage to keep to 10 because we've got it there. Right. And then the final thing we're going to be doing is just dropping down a pack node. So we'll call it pack. We say geo.create node pack. Oh, and again, I'm assuming that it's pack, but let's double check, and it is called pack. Right. Create that pack node, say pack.setInput 0, and we're going to plug it into our polyreduce node, right? Okay. Now that's going to give us most things, right? It's going to give us that last node, but we know that they keep ending up on top of one another. Like they literally are like this every time. Okay. And that's not what we want. Now there is a cool thing. You see when I clicked L and everything got laid out, there's a kind of a way of doing that, which you run the function on the parent and it lays out all of the children inside of the node. And we'll actually find that, and it's called layout children. So automatically position all or some of the children in this node in the network editor. Okay, you can choose the spacing and that type of stuff, or give it a specific list of items, but all of these are defaults. It's got default spacing and it's got a default empty list, which means it will do all of the items. And we do want it to lay them all out. Okay, so we don't need to give it any arguments. All we're going to do is say geo.layout children. Okay, so let's do that. Let's go test that now. Let's see if this works. Go up, apply. It's a good thing that there's no errors, by the way. If you are getting errors, make sure that you then work through the errors and find out, read them carefully and find out what they're doing. I see here, laid out nice and neatly, polyreduce set to 10, everything's working fine. If we move our display and render flag to the end and middle click, you'll see here we've got a packed primitive. but we have a poly-reduced version of it. Okay, we can even see the, well, you can't see polygons when it's reduced, but anyway, there we are. It's poly-reduced and packed. Perfect. Now, we had to still manually move our display and render flag, and that is the final step to this, is to just add that. Now, I mean, we can do that wherever. We can do it here before or after the laying out of the children. So what we're going to do is, remember, we need to set generic flag, and then we need to choose the flag type, which was the display flag and the render flag. Please do not use the old set display flag and set render flag functions, because those will become redundant at some stage. So what we're going to do is, it's on the pack node that we want to set the display and render flag to. So we need to reference pack itself. So we're going to say pack dot set generic flag. Okay, now let's just pull up that function and make sure we're going to do it correctly. So set generic flag. We need to give it a flag type and then a value. Okay, so the flag is a who.node flag, and I'm getting that from here. It says it's specifically a who.node flag, and when I hit dot, it's going to give me a list of the options. One of them that I want to do is display. So who.node flag.display, and the value I want is to set it to be true, because I do want this to be my display flag, so set it to true. I'm also going to do the exact same thing, but to who.node flag render instead of display. Okay, so one last time, let's delete this. Let's go up here, let's apply, no errors, which is good. We jump inside, we see that we have an unpack, a poly reduce set to 10, a pack, and the display and render flag is there. It's all laid out, all plugged in correctly, everything working. But it's done it to only one of the nodes because we're breaking the loop after the first iteration. So all we need to do is inside here is go and delete that. And now, I mean, look at this. It doesn't even matter if we have a ton of these. So think about how many nodes are in this selection here that we would have to go and manually do that all for. Okay. And instead, if we now just click with them all selected, we click apply. It's going to take a little while to think, but it is essentially running through and saving us hours of our life. And it's not even just about the time. It's the frustration, the boredom, I mean, it's just not very fulfilling to sit and do that a million times. I mean, sure, you could do it a little bit smarter. You could create the 3 nodes, copy it, and then every time you dive into a node, you could paste. But really, who has the time and energy to do that? Now look at this. I'm going to delete all of them except one, just so that we can see it more clearly. But you'll see here we have a fully poly-reduced Alembic archive because of what we're looking at. And in fact, sometimes we would even, because actually the scenario when I had to do this at the actual studio, we were actually setting this display flag on here, but the render flag to a separate null, so that essentially when it rendered at full res, but it displayed as a poly-reduced version. So it would be something like that. Okay, same thing. You could just easily set this up in this. Right. In fact, I challenge you guys to do that as a little, as a way to practice this, is go and actually change it so that you create the null and plug that in with the render flag set there. Okay. All right. So that about wraps it up for a good practical example. What I really wanted to get across to you is not so much that these specific examples are useful, although they are. These are things I have literally had to do. These are not just made up for the class. But the point is that Python can be used on the go. It can be used to just create an ad hoc script that helps you achieve something really quickly. You don't want to have to click things a million times or whatever. Just use Python in the shell, so the Python shell, the Python source editor, and just write code to make your life quick and easy. All right. So thank you very much, everyone, and I will see you in the next lesson.